In this video, we're actually going to look at how to solve quadratic equations by completing the square. In 10.3 Part A, we looked at how to find C to complete the square. You take half of b, which is the coefficient of x, square the result of step 1, and then add it to what we already had. So to make my left side of the equation look like what they had to do their completing the square, first we want to subtract 5 from both sides. So now I'm ready to do their steps. I'm going to take negative 18 times a half, or divided by 2, and square it. So negative 9 squared is 81. And we know that if we add 81 to one side, we need to add 81 to the other side as well to keep our equation balanced. So now I call this the shrink it step. We're going to write this as a perfect square, and we know what our constant is going to have to be. It's going to be x minus 9 squared equals 64. And remember, the reason we know that, every time if we're looking for what this would be as a perfect square, if we take the square root of 81, I get 9, and negative 9 times 2 is the negative 18. Now that it is a perfect square, I can take the square root of both sides, so I have x minus 9 equals plus or minus 8. Add 9 to both sides, so x equals 9 plus or minus 8. 9 plus 8 is 17, and 9 minus 8 is 1. It's always a good idea to substitute back into the original equation to check. 17 squared is 289. Minus 306 plus 5 is negative 12. I like it. Same thing with the 1, putting it back into the original equation. 1 squared minus 18 plus 5 is supposed to equal negative 12. And 1 minus 18 is negative 17 plus 5 is in fact negative 12. So I know that my answer is right. On some of the problems, we start off with a lead coefficient other than 1. So now our first step is going to be to divide both sides by 9. And obviously the 9's cancel out was the goal. 12 ninths we could divide by 3, so that would reduce to 4 thirds. Minus 1 ninth equals 0. And now we're back to where we were in the other one, so we're going to move the constant to the other side. So add 1 ninth to both sides. 0 plus 1 ninth, of course, is 1 ninth. And then to find what we need to complete the square, we're going to take the coefficient of x, which is negative 4 thirds, times a half, which is the same as dividing by 2, and square it. So we can cancel the 2 and the 4. So I've got negative 2 thirds squared would be 4 ninths. So I know I need to add 4 ninths to both sides of the equation. And conveniently, I already have a common denominator. That's nice. And so just like the other one, I know what goes in there to complete my square because I already have it. Equals 1 ninth plus 4 ninths is going to be 5 ninths. Take the square root of both sides, so x minus 2 thirds equals plus or minus. Square root of 5 over the square root of 9 is 3. Now I can add 2 thirds to both sides, and if the directions said get an exact answer, we would be done. But in your textbook, the directions say round to the nearest tenth if necessary, so we need to type it in the calculator. And when I add, I get 1.4 rounded to the nearest tenth. And when I subtract, I get negative 0.1 rounded to the nearest tenth. Suppose the rate of flow of an 80-foot wide river is given by the equation r equals negative 100th x squared plus 0.8x, where r is the rate in miles per hour and x is the distance from the shore in feet. Jacqueline does not want to paddle his canoe against a current faster than 5 miles per hour. At what distance from the riverbank must he paddle in order to avoid a current of 5 miles per hour? I'm going to move the r to the right side because that's where we're used to seeing it. I don't know about you, but I'm not very crazy about that coefficient of negative 100. So I'm going to divide the whole equation, both sides, by negative 100. So now I have something that's a little more familiar. X squared minus 80x equals negative 500. To find c, to complete the square, we're going to take negative 80 divided by 2 squared. So we have negative 40 squared is going to be 1600. So that's what we need to add to both sides of the equation. And once again, I know what my perfect square is going to be. So it's going to be x minus 40 squared equals 1,100. Okay, now when I go to take the square root of both sides, I'm not feeling that's probably a perfect square. And sure enough, when I type it in the calculator, I got 33.17 and some change. I rounded to the nearest hundredth. Why not? So if I move x, or the 40 to the other side, I'm going to have x equals 40 plus or minus 33.17. If I add, I get 73.17. If I subtract, I get 6.83. Now remember how wide the river was? 80 feet wide. So if I subtract 80 minus 73.17, do you know what I get? Yup. So the answer that makes sense is the 6.83 feet, because if he's 73.17 feet from one shore, he's 6.83 feet from the nearest shore. And who's going to be counting to the nearest hundredth of a foot when you're in a river? So probably 7 feet would be fine. Complete the square to make a quadratic equation a perfect square. Use the following steps to complete the square of x squared plus bx. Find 1/2 of b, the coefficient of x. Square the result of step 1 and add the result of step 2 to x squared plus bx, the original expression. Then we can go back to our, hey, find the square root of both sides and finish solving.